Now, up next, here next to me, of course, already, is Brian Aker, another person who needs relatively no introduction. He's the one who coined the term MySQL ecosystem years ago. He was also the director of architecture at MySQL. He's been the lead developer on Drizzle, Memcached, and excuse me, Gearman. And he's currently a fellow at HP, leading their PaaS engineering group for HP Cloud. So join me in welcoming Brian Aker.
First thing I'd like to say, it's really amazing to look out in the room and see this incredibly full audience. And if there's anything that probably all of us will stand up here and we've been at these conferences for. See, I remember the first conference. And the first conference in my mind is the Open Source Database Conference that occurred right after 9/11. And it was sponsored by Rackspace. And there was all about 30 or 40 of us that found a way to get to Rhode Island for the actual conference a week later. And I believe that's kind of where most of this stuff starts. So looking back on over a decade, it's still pretty incredible to see the size and just the interest in the technology. So what I'm going to talk to you about today, there's a little self-serving in some of this with the HP, what I'm going to announce. And a little bit is what I've been actually seeing and observing in the MySQL ecosystem for the last year. So what we've done is what I believe is the cloud era. So the history of MySQL in the beginning. MySQL in the beginning was about batteries included. We had a database. What did we do? We found some people who needed to ship that database because usually they wanted to replace Oracle as a database in their product. So it was basically a batteries included business. The web market, well, it looked like something, but they didn't necessarily have to pay anything. They weren't required to pay. They could use what they wanted to use. The whole rocket fuel that set off the rocket in the beginning all was about, I have a product, I need to replace Oracle, can I fit MySQL into the back of that product and do that? And that's really where we start things off. Where do we go from there? The next part, as I usually refer to it, is we started entering the enterprise era of MySQL. The enterprise era of MySQL a lot of it was feature creep. What we ended up seeing was 4.0 came out, we had replication, we had the ability of it wasn't even so much that we needed a transactional storage engine. What we needed was a storage engine that for whenever the machine died, whatever occurred, you came back and the data was still there. You didn't have to go and tell your boss, well, it's going to be like an hour or two before the index is rebuild, and then we'll have the website back. None of that stuff. Really, transactional, what it really came down to was, did my data return when the box went down? And replication was our scale-out story. It was a read-only scale-out. There's obviously, large problems with that when you kind of run into large scale, as far as like one disk write equals many disk writes. And after that point, we kind of started going after the enterprise business. The enterprise business, kind of feel like we were a little lost in the woods at that point. We saw a lot of feature creep. We saw a lot of, we must have these things. I think one or two people have the old MySQL shirts on it that say MySQL 5.0. We had this feature, that feature, an extended feature. And those features, there were definitely some markets for them, but our core, the people who were actually really, really interested in what MySQL was doing, they weren't really so much caring about that stuff. So we entered the actual enterprise era. So, and also in the early era, we ended up with what? The GPL client license problems. People would come up going, well, my application, it does this and this, do I need a license? And this created all sorts of problems. We could even watch Richard Stallman sit around on a stage and kind of dance. Got him doing that on YouTube somewhere where he had explained, so GPL, does it actually follow the protocol? Is what MySQL telling everyone actually correct? And Richard raised his hands going, well, kind of does, kind of doesn't, because nobody was really very comfortable with that. And the GPL client license issues created all kinds of murky issues, created questions why people would actually use the database. This was actually a fairly big deal. We also saw this as a trending problem. This, by the way, shows about 0.6, and it shows up to today. Job trends. MySQL DBAs are still in high demand. This was something we didn't do a lot about. This was something that was still needed. Today, if you are actually a MySQL DBA, and if I was to ask you all to raise your hands who were MySQL DBAs, what you would suddenly find is right after this talk, a flock of recruiters coming to find you from any one set of companies here. I look at the vendor list, and what do I see? Company after company who would pretty much are here. The technology is interesting, but they need to hire more DBAs. And this has been an ongoing problem and we didn't do a lot to solve it, little attempts to it. So DBAs are not included, something we thought about. We got ease of use, but we didn't really get rid of the whole DBA problem. So, you know, questions of, well, how far behind is replication day? All these things that still require a human to sit there and check things out. So what I think we've now been entering for the last couple of years, really, is actually the cloud era. And we had bits and pieces of things. It's funny, we were talking about, you know, I look at MySQL 5.5 and look at 5.6, and I'm like, yep, I remember. That's the roadmaps I wrote. Huh, glad to know. I'm curious what they're going to do after 5.6. Didn't leave many cliff notes for them for what to go after that. And some of the pieces that have actually been removed, anybody ever thought what the instance manager was about? Bringing up multiple MySQL instances on a single box, controlling resources, and being able to provision. Does that sound like something we were thinking about that was all about cloud? Glad they cut that feature. They could probably see the vision in that. So here we enter the cloud. Things are actually looking a lot better in the environment. There's no distribution, no GPL concerns. People running MySQL, they're the cloud vendors at this point. That's where we see. We see all this movement to people saying, I don't want to run a database. I don't want to worry about the scaling features. I don't want to worry about these things. Let me go build my application. So MySQL is now entering the cloud era. And the GPL concerns of the past, well, not so much. We actually do what? We don't distribute anything. We run MySQL in the cloud at this point. We provide it to other people, but there's no distribution. Your applications are your applications, the way it should have always been. That means however you do, whatever you're doing, that is your situation. And if you think about this from the storage engine ISV standpoint, suddenly we actually have a market. The storage engine vendors have a way out. You know, I've heard the stories of what happened at the first storage engine meeting with Oracle after the EU required it. Didn't sound like it turned out to be like that great of a meeting, nor was there one afterwards. Well, guess what? The cloud changes everything. If you can actually launch your software into the cloud and you are controlling your software, you're the one handling everything, distribution doesn't occur. GPL doesn't matter. So the cloud re-enables all those businesses that people thought, well, you're kind of left high and dry at this point. That's not the case at all. We can see that from a number of the storage engines that are out here. Notice, they're running in the cloud. They're not distributing. Other things. Cloud solved one of the problems. How do we handle that graph back there? How do we handle this graph suddenly of like, this is the amount of population that actually know MySQL. It's only growing so rate. MySQL growth continues to grow thanks to all the cloud vendors. That's where growth is occurring. Well, management's included in the cloud. We actually start cutting that stuff out a little bit. We don't see quite the need for it. That's one of the great things about moving into this era. Also, we got a whole lot lower upfront costs. People sitting there going, well, we bought these 2 big boxes that were like SSD, and we thought that like, we got, 128 gigs of RAM in them, and then we discovered the average data set for most companies is about, 20 gigs. It's actually not that big. So all that hardware costs and stuff, pop them out. So, and here's also, the fear of Oracle now is largely irrelevant. That doesn't mean like a fear of, that doesn't mean Oracle, bad guy, anything else. I think I've blogged several times. They've been doing a good job on releases. They've actually been taking things, making releases happen. And I keep a look at the code trees. I do a BZR poll on it with some frequency, and look, the changes I see are very good engineering changes. These are not bad changes. They're doing many of the right things. That's pretty cool to actually see. But the fear of Oracle, that fear people have of Oracle, and its salespeople, and lawyers, it doesn't really matter anymore. This is all irrelevant. We've moved in past that point. So that fear itself should be taken out of the market. And if there was one thing I saw right after the Oracle acquisition announcement, I was at O'Reilly's Foo Camp. And I ran 2 or 3 people who were like, yep, we're ready to ship with MySQL. We've done it. We moved to another database, couldn't handle this. Oracle, scared of them coming in. I've run into at least 2 of those guys in recent years. And they were like, yeah, turns out, wasn't really a big deal at all. We actually just moved back to MySQL. I'm like, huh, that's interesting to see. Fear of it's over with. Here's also the thing. SQL is pretty much complete. You look through the things past the SQL 92 standard, we see like all the object-oriented stuff in like 99. We look and see what these other components that have been added. And the truth is, like, the percentage of users is very, 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 very small. What we really see is the basics. The basics are what people care about. The basics are what is done. For the most part, features, we can find few pieces here and there, but the core of the language and the core of what we need today, it's pretty damn expressive. In fact, more expressive than what most developers can usually wrap their heads around. Feature set is pretty much done. So a lot of what we're talking about right now is how do we harden it, make it better, how do we make it more performant. But the feature parity stuff, that's pretty much largely gone. SQL, by the way, is still in also demand. These are stuff that I've always been amazed at. Oh, so you have a NoSQL solution. NoSQL solution. Do you have put together your SQL interface yet for that new SQL solution? Oh, you have. Cassandra, Tarantool, Hadoop's, Hive. You look down the list, every one of them now have in some form of SQL solution around them. My numbers from what I've seen of the Hadoop's Hadoop, majority of users out there in Hadoop land actually use a SQL-like interface. You know, SQL's a real pain, but it actually is still around and expressive. So there's still a bunch of challenges. It's not like cloud's going to actually solve everything that we worry about. Disk I/O. Disk I/O is still a big problem. Disk I/O was a problem when you bought your own machines and you had to sit there and go, well, did my disk controller lie to me? Is it really actually saving disk? You know, is it actually sitting there? Is the cache actually working? Did I set up things correctly? Disk I/O has always been a problem, and in the cloud, we still see this as a problem. And this is something that, you know, we get into essentially the other problem, which is that, did it turn out to be network I/O? Where is your disk I/O really? Is it on the local box you're doing? Is it all across the SAN? Is it across a NAS? Where is it? You know, did the provider over provision testing tools to figure out what your long-term disk I/O is going to be? You know, we saw tools go up, you know, 5, 6 years ago that were all based on like, hey, is my disk actually saving data? You know, and the benchmarking tools we don't have right now for the cloud is essentially the tools that say, did my database continue to run at what I expect it to for some period of time, or am I getting I/O hiccups? There's a lot of little pieces here. The cloud's not perfect. We still got a number of things to work on. And virtualization at this point, virtualization is still costly. A lot of the solutions we were looking at in virtualizing, there's about a 30 to 40% hit when we actually go into virtualization, which means we can buy bigger boxes and, you know, do virtualization. But plants only got so much electricity, and I think 6, 7 years ago, TED Talk described it as 7% of the current planet's output for electricity. Data centers, virtualization can be very costly. Multi-tenancy issue. Multi-tenancy issues are still a big deal, you know. You may be doing fine, but who are those neighbors on your box? What are they doing? Did they just get, you know, pounded because some, you know, website put them on the front page and they wrote some poorly designed application that has no indexes? Well, didn't you just reach out and look at their database and go, if we just put an index here and there, we could solve this problem, right? Then you wouldn't be trashing my network too, because, you know, my mother wants to see my pictures of my kids and they're running on my website. You know, multi-tenancy issues. You don't really know what your neighbors are. This flips back into, so why am I here in the first place? Because, you know, normally I'd be up here talking about Drizzle or something, but why am I up here in the first place today? How does HP fit into this? HP fits into this to a thing called OpenStack. Right around July of last year, HP approached me with the, by the way, here, sign this NDA and we'll tell you what we're going to do. Okay, well, I ain't signing the NDA. You want to tell them what you're going to do? Okay. And at the time, I got to see the first demo of HP Cloud actually running OpenStack. For all of you who are not familiar, OpenStack is an Apache 2.0. Basically, take Amazon-like services, and here you go. Here's the code. Been built by NASA, been built by Rackspace, been built by HP. And since then, we've had Intel, Cisco, you name it in the industry has signed up. This is an entirely open platform for doing cloud computing with APIs that there's no, you know, well, are we going to get sued because this other company kind of lightly threatens that we might sue you if we actually do your APIs and all this other FUD. All that FUD is gone. It's entirely open source. And it's an entirely Apache 2.0, so licensing issues, not really there. This is where my group concerns in. My group's been working on something called Red Dwarf. This is something actually started by Rackspace, and it's an enabled PaaS components to be developed on OpenStack. So where OpenStack initially launched with compute and storage and identity, Red Dwarf makes up that next piece. It's the PaaS component. In our particular area, what we were looking at first, when we first worked on, was the DAS implementation. So database as a service. It's community, Apache 2.0 licensed. It's out on GitHub. And on that note, let me show you what we've actually been doing. And to demonstrate this, I'm going to have Vipul come up. He heads my dev lead for engineering around Red Dwarf at HP.
Okay. So is this ready to go?
Yeah.
Okay. All right. So actually, let's pause it for a second. I'm a developer on the HP Cloud Databases and Service team.
I'll miss this.
I'm going to buckle. We've been developing a RDS-like solution for OpenStack. We've been building it on open standards. We have code that's out in the public currently. We integrate with OpenStack Keystone, OpenStack Swift, OpenStack Nova. And today we're going to do a demo of it in action. So first thing is creating an instance. So the only thing we need to actually provide is an instance name. We can call it my database instance. And we're using a CLI here, but the thing to note is everything is a Rust interface. The response we get back, we get a unique password, and every instance is assigned a public IP.
Before anybody runs off, we did delete the instance afterwards, so.
Yeah. So then, before we can use the instance, we need to check that the status of that instance is actually up and running. So we can do a list instances call, and we get a status that says we are running. So once we get this, we can use the credentials that were previously given to us and attempt to do a login to that instance, which we'll show next. You can use, so we haven't modified MySQL in any way whatsoever, so you can use any MySQL CLI or command line tool to actually log into that instance. And this is going to show that we are actually doing that. And so one thing to note here is that what you get back is a finely tuned Percona 5.5 server. So we're not doing anything to that, to that distribution at all. So next thing is SQL import. We should be able to use any standard tools out there to load data into this instance. And we're loading the employees database here. It's developed by one of my colleagues, Patrick Cruz. It's not the HP employees database, even though you see an HP there. It's a sample database. To prove that I'm not making all of this up, we can actually log in and visually verify that the data actually does exist on this instance. So we'll use a graphical tool this time. We'll go to the employee schema, and we have data. And one thing to note here is that actually that got hidden, but there was about 3 million rows in that salaries table. So now that you have a database with data, you may want to back that data up. So you can schedule this periodically. There's an API to create snapshots. The only thing that we need to provide is a name, a friendly name that you want to identify the snapshot by, and a instance ID, the instance that you want to take the snapshot of. And once again, once the snapshot actually is being created, you'll get a status of building, and you'll have to check that periodically to see if it has indeed been completed. To check that, we can use the list snapshots API, and notice that the status goes to success, which means that we actually have a snapshot that's been replicated across many AZs.
The API behind this, by the way, is a fully RESTful API. It's been implemented and designed within actually the Red Dwarf community. So the idea is standard APIs controlled by the community, understood by the community, and so forth. So this is where part of the power behind open source actually is.
Okay, so now that we have a data backup, we may want to create an instance from that backup. So again, it's the same create instance call. We name our instance, and this time we provide an additional parameter, which is the snapshot ID that you want to create the instance from. And at this point, you should notice that there's a new IP address and another unique password. To check that the instance actually has come up properly, we can do a list instances and give that instance ID and check that the status switches over from building to running.
Security on the databases, by default, within everything inside HP Cloud, we start by very secure to allowing you to downgrade security. So when you get your database instance, you have to enable what machines you want to connect to. So whether you have the connect to machines that are local inside of HP Cloud to a set of machines, to if you want to open it up and connect to machines outside on the internet, we'll allow you to do that. But we start with the most secure state, and we then let you decide how far back you want to go as far as less secure.
Right. All right, so with this new instance that we just created from a snapshot, we can verify that the snapshot data actually does exist on this instance. So we'll log in once again. You'll notice that there are 2 tabs this time. One was the previous database, and this is our new database. And once again, we have 3 million rows in that table. Finally, so if you noticed, we were only returning the password when you create an instance. This is because we don't actually ever store the passwords. So we expose 3306, so you can always go and change the password, but we never have a record of that password. If you happen to forget the password, we do have a reset API that gives you another unique password. And this password can be used, once again, with any SQL client and to log into that instance. And at that point, you should probably reset that password once again. And yeah, so that shows that we did log in. And finally, what we're going to do is we have a couple of database instances. We should probably, once in a while, clean up some of these resources if we're testing. So we have a terminate instance API. This allows you to just get rid of that instance and not get billed for that anymore. We do take a snapshot when you terminate your instance. Mm-hmm. So in case you need that data, you can always recreate that instance from that snapshot.
Which also means you can do things like, we don't need the database for this time being, we don't really want to take the cost of running it. You can do a snapshot, store that back out to Swift, and then when you want to call that instance back, we can actually pull that instance back up for you, and you can have a running database. So you can have those transient style databases whenever you need to. And of course, you can copy and replicate those things so that you can have multiple instances of the same database. So if you need to take a snapshot for some kind of QA, we can do the snapshot, store that, and then bring that up for you for actually doing any kind of QA or other development work.
And that's pretty much a demo. I'd like to just, this slide is to give a shout out to the Seattle team. This is the database as a service team. We're based out of Seattle. We are currently at 10. We probably plan to grow quite a bit here, and we are going to be ramping up a lot of features here soon.
Yeah, thanks.
Yep, thank you.
Thanks. So that was one of the things that Pass Engineering's been working on, at least what we're going to announce this week. There's some principles, by the way, in here that I think are also important that are behind the design. All of Red Dwarf and our setup is actually designed so that at no point do any of us actually log into the database itself. I'm really always kind of weirded out by the concept that somebody else would come in, pull up the MySQL prompt, go into my database, and go look at my data. We've designed all the software around MySQL such that at no point do we actually log in. We can do all changes that we need to. We can make anything happen. But we never actually have to go to the MySQL prompt and get access to the database itself. So this has been one of the defining principles around security and around data privacy. A second thing is snapshots. When we talk about snapshots, the snapshots themselves are actually encrypted. So they're encrypted, stored in Swift, at which point, once they're in Swift, that means they're actually sent through all of our different AZs. So it's not only one data center, but it's multiple data centers. So if a plane comes along, hits the building, well, all your data is actually stored in another data center as well. And I think this is kind of important for when we call disaster recovery because, well, you never know what's going to happen. And this means that, well, where's my stuff in the cloud? Well, in our cloud, it's going to actually be across multiple availability zones. So all snapshots, they can appear wherever they need to appear. This thing's also, we've worked really hard to make sure that it's integrated with OpenStack. So things like Keystone for identity management, we're actually building stronger bindings into that. It's funny, people don't use the SSL connection stuff to MySQL much. We're going to look to change that. Security actually is important. Swift, we talk about snapshot instances, all that is actually stored in Swift. We actually use the environment that we have built in, the OpenStack environment. And Nova is what we handle and use for our compute. So everything you see being pulled up, that's being pulled up in Nova. And so we use that actually for the virtualization. And it can be a very light virtualization if you tune it right. Nice thing about OpenStack and this whole thing, even if you look it up here and say, well, I don't know that I want my stuff run in the public, with OpenStack, you can go run it on premise. You can go find DevStack today. You can pull up an image of it that you can run on, you name it, laptop via virtualization, Linux directly. You can run it on premise. You can go look at the tristack.org stuff if you want to try building out a data center. Everything here is actually open source. So it's not like you're going to be tied to any single vendor. So if you're interested in trying out the beta, you can go sign up at hpcloud.com. It's now, I believe it's public, so anybody can go and sign up for accounts, and we start onboarding people somewhat slowly to see how the whole thing works. But anyway, pretty excited about it. So thank you very much for your time.